Good morning, everybody. Welcome to a rainy Tuesday morning of Chem 1211 with your host, me, Dr. White. Hi. All right, here's today's game plan. First of all, I'm going to be going through the gas problem set. Then I will go through the lab we'll be doing today. And I have some important things to talk about when we do the lab. And then afterward, because of, how should I say this, the problems a number of you had on test number 1, after the lab, what I will be doing is I'm going to go through some key points on how to use your good buddy, your good friend, unit analysis, working with mole problems. If you don't know how to do those mole problems, you're going to have trouble with quiz number 3 coming up a week from this Wednesday. I wrote it last night. Sometime today, I'll post quiz number 3 review, quiz number 3 important information, and next Monday, I will do a review for quiz number 3, which will be online next Wednesday, and you'll have until Thursday morning to take it, finish it, and upload your answers. So that's the game plan for today. And with that, first of all, don't forget to hand in the lab that's due today. We did last week with the cards. Make sure you take at least one picture, or I'll take off 1 billion points, not 1 billion, but at least 1 or 2 if you don't include a picture of your hand or something with the cards. And I'll mention it during the lab, but I better mention it now. If you have a marble or quartz top for today's lab we'll be doing, make sure you either do it in the sink, hopefully it's not marble or quartz sink, or take a baking pan and use that as a tray, because some of the things will, how should I say this politely, negatively harm a marble top. And you don't want that. Or if you live at home, your parents don't want that. I don't want that. All right, let's get going. All right, thumbs up, people. Everybody see chapter 11, gas problems, on your screen. Thank you. All right, now, one of the key things you should know is how to convert pressure units. And I don't have it open, so I better open it up. All right, everybody see 760 torr equals 760 millimeters of mercury on your screen now? Thank you, Gianna. Oh, you're both Gianna. I've got G squared today. Or Gianna in stereo. But anyways, thank you for coming to my class today. This will be given to you, but you need to know how to use it. And let's go through some of the key things that you should know. How many torr is 41.5 mm is millimeters Hg mercury. And here's what we have. We're trying to find torr. We're starting with millimeters of mercury. Here's what we have. We want to get to torr. Whatever you're trying to get to goes on top of the ratio, and whatever you're trying to get rid of goes underneath. Now, I have 1 and 1. You could also put in 760 and 760. These are exact numbers, 3 significant figures, 3 significant figures. Same thing here, going from torr to millimeters of mercury. These are exact numbers, 4 significant, 4 significant. Now, let's look at number 3. How many ATM that's short or abbreviation for atmospheres, is 741 torr. We're trying to get to atmospheres. We're given 741 torr. And notice I have here note, this you'll be given an important information, quiz 3. In the past, students had to memorize this. I've changed a couple of years ago my philosophy on that. But you still have to know how to use it. We're trying to go from 741 torr to atmospheres. Use this ratio. How do you figure out that ratio? Whatever you're trying to get to, the units go on top. Whatever we're trying to get rid of, the units that we want to get rid of go underneath. And where do we get a relationship between atmosphere and torr? 760 torr equals 1 atmosphere. 760 torr, 1 atmosphere. These are exact numbers. 3 significant figures. Your answer, you need to round off to 3 significant figures. Now, if we look at number 4, how many torr is 1.237 atmospheres? Again, this is a key thing. And you should know how to do for quiz number 3, all these conversions. And here I'm wanting to get to torr. I'm starting with atmospheres. Here's what I start with. I'm trying to get to this unit. Again, look at the ratio. Whatever you're trying to get to, the units go on top. Whatever you're trying to get rid of, the units, in this case ATM, go underneath. And again, 760 torr equal 1 atmosphere. 1 atmosphere, 760 torr. These are exact numbers. This is 4 significant figures. In this case, my answer is 4 significant figures because that's the only number you have significant figures for. I can't stress enough, watching me do this is not the same. Open up the problem set without the answers, try it, and then come and open up the answers for those problem set. All right, let's look at number 6. If a balloon, or it could have a piston like I have in 7, but let's look at 6. If a balloon has a pressure of 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.133? Now, the initial pressure we call P1. The initial volume we call V1. The final volume we call V2, and we're trying to find the final pressure P2. Now, let's once again look at important information, quiz number 3. And if you notice right here, I will give you at the end of the test an important information, quiz number 3, Boyle's law. P1 times V1 equals P2 times V2. And notice I will give you P1, the initial pressure, V1, the initial volume, P2, the final pressure, V2, the final volume. That will be given to you. Like I said, a number of years ago, students in my 12-11 class had to memorize this. And like I said, this will be given to you at the end of quiz 3. The packet, not when you're done. But anyways, now, if you look over here, you're trying to find a pressure, and all you're dealing with is pressure and volume. Immediately that tells you Boyle's law, which you're given, P1 times V1 equals P2 times V2. Now, we want to solve for P2, which means we want it alone on one side. How do we get rid of V2 to have P2 alone? Anything divided by itself is number one, means it's gone. So I divide this side, P2 times V2 divided by V2, and I get 1. 1 times P2 is P2. However, whatever you do to one side, in this case divided by V2, you have to do to the other. So we now have P1 times V1 divided by V2 equals P2. Now over here, I like to rewrite it. I think I've mentioned it once, twice, or 1,000 times. Good habits I don't change. So I'm just rewriting it. P2 equals P1 times V1 divided by V2. Now, we took the time to figure out what was P1, the initial pressure, V1, the initial volume, and V2, the final volume. So we can put that in. And notice this is 3 significant figures, 4, 4. When you're multiplying and dividing, the number you have, your answer should have the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures, 3, 4, 4. My answer is 3, and you'd have to round it off from what's on your calculator. Now, in number 7, again, look at what you're given. A volume, that's your initial volume, and a pressure. And pressure can be in either millimeters of mercury, torr, or atmospheres. Volume, I always stick to liter. And here, we're trying to find what is the volume when the pressure is changed, reduced. Well, that's the final volume. The initial pressure is this. The initial volume is 22.4 liters. The final pressure is 3.567 atmospheres. When you see a problem that only has pressure and volume, you know Boyle's law. P1 times V1 equals P2 times V2. Again, this will be given to you right here in important information, quiz number 3. And if we go back, we want to solve for the volume. We want it alone on one side. How do we get rid of P2? Divide by it. Whatever you do to one side, you have to do the other. Anything divided by itself is 1 times V2 is V2. So you have P1 V1 divided by P2 equals V2. I like to rewrite it. You don't have to, but I do, because I like to do it. In good practice, I don't change. All right, V2 equals P1 times V1 divided by P2. We took the time to figure that out initially, what P1 is, V1, and V2, P2, and 4, 3, 4 significant figures. My answer is that. Let's skip number 9 and let's go to 10. If you burp, and this is going to be a monster burp, 6.75 grams of CO2 at 545 millimeters of mercury at 34.6 degrees C, then what is the volume of your burp? Now, if you notice this, plus I'm missing something there, 15 points. Yep, 15 points. But if you notice, you're not changing any of the variables. You're just asked to find something. And you're dealing with a gas. And what does that mean? It means you should use the ideal gas law. PV equal nRT. This will be given to you in quiz number 3, important information. And notice P is pressure and the units are critical. If you have the wrong units, you'll get the wrong answer and you'll lose a lot of points. And the volume, I'll always ask you or give it to you in liters. N is the number of moles. You'll never see it in moles. You'll be given grams. I'll talk about that in a second. T is temperature in Kelvin. I've never seen a thermometer in Kelvin or any temperature measuring. It's usually in degrees C, and you'll have to convert to Kelvin. And finally, R is the universal gas law constant. And for this class, use 0.821 atmospheres, liters, mole K. Now, just to remind you, important information, quiz number 3, I will give you the formula Kelvin equals degrees C plus 273. Now, what if we look at this? We're trying to find the volume, V. We're given a weight, 86.75 grams of CO2. We're given a pressure, excuse me, a pressure 545 millimeters of mercury. We're given a temperature 34.6. And because I'm going to be using PV equal nRT, in important information, you're given R equals 0.0821 atmospheres, liters, mole K. Now, here's PV equal nRT. What are we being asked to solve? Volume. So I have to get it alone on one side. How do I get rid of P, the pressure? I divide by it. Anything you divide by becomes the number 1. 1 times V is V. But whatever you do to one side, you have to do to the other. So I divide by P. And now I have V equals nRT divided by P. Now, the pressure, as you see, let me show you it again. The pressure has to be in atmospheres. N is the number of moles. T is the temperature in Kelvin. So we've got to get to work converting what you're given into the proper units. For pressure, we did this, just did this type of problem. We're starting with millimeters of mercury. We want to go to atmospheres. Oh, I haven't done it all morning. And it's time to use your good buddy, your good friend, unit analysis. And bet you thought I couldn't go through the whole lecture without doing that. You're wrong. But anyways, whatever we're trying to get to, atmospheres, goes on top of a ratio. Whatever we're trying to get rid of, millimeters of mercury, goes underneath the, or on the bottom of the ratio. Where do we get these numbers? Important information. 760 millimeters of mercury equals 1 atmosphere. 760 millimeters of mercury equals 1 atmosphere. Therefore, 1 atmosphere, that's where I got the 1, equals 760 millimeters of mercury. Notice millimeters of mercury divided millimeters of mercury cancels out. I like the special effects. Cancels out, and you get atmospheres. The 545 is 3 significant figures. Remember, all non-zero numbers are significant, and the 1 and 760 are exact numbers. So my answer here is 3 significant figures. Next, we need temperature in Kelvin. We have it in degrees C, and Kelvin, as you saw, important information, quiz number 3, is degrees C plus 273. Degrees C 34.6, added to 273. 273 is an exact number. The only number to determine significant figures for the addition is the degree C. You get the same number of significant figures to the right of the decimal as the number that has the fewest. Well, you only have one number to deal with, one past the decimal, and you keep that 0.6. And finally, we want to get N. N is moles of carbon dioxide. We have the grams, 86.75. We want to get the moles of CO2, carbon dioxide. And it's time to use your good buddy, your good friend, unit analysis. And I'll be doing this exact type of problem after the lab because a lot of you had trouble with this on test number 1. But for now, whatever we're trying to get to goes on top of the ratio, moles CO2. Whatever we're trying to get rid of, grams of CO2, goes underneath. Where do I get those numbers? If you look at important information, quiz number 3, and this I'm going to be changing because this is the old one before I knew I had to give quizzes, not tests. 1 mole of a compound equals the molecular weight of that compound. 1 mole of a compound equals the molecular weight of that compound. And the molecular weight of that compound is the sum of all atomic weights in that compound. So 1 mole equals the molecular weight of CO2. Well, you've got to calculate it. There's 1 carbon, 2 oxygens. Each carbon, and hold on because I don't have it open, you will be given a periodic table. And if we look at on quiz 3, it will say underneath your name, like test number 1, please use proper significant figures for all calculated answers. And it'll also say, once again, please use all atomic weights, the three significant figures. And carbon, 12.011, the 3 significant figures, 12.0. Oxygen, the 3 significant figures is 15.999. No, round that off, 16.0. Oh, hang in there. I always forget this. All this I'm doing now is in the same PDF. All right, now 1 carbon at 12.0, 2 oxygen at 16.0. Do the math. 1 times 12.0. Remember, 1 and 2 are exact numbers, so it's 12.0. 2 times 16.0, 32.0. Add them up together. Remember, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. And in this case, they both have 1, so it's 44.0. This 86.75, 4 significant figures, 1 exact number, it's the definition. This we calculated as 3 significant figures. So our answer is 3 significant figures. Now that we put pressure, temperature, and moles into the right units, we can put them in. V equals nRT divided by P. N, the number of moles. R, well, you're given that, and you'll be given that important information. 0.021 atmospheres liter mole K. Kelvin, temperature in Kelvin. And finally, pressure in atmospheres. Common mistake students make on quiz number 3 type problem like this, they put in just the units you're given here. They forget you have to convert. And if you don't convert, you're going to get it wrong and get 0 points, not the 15. Ooh, yeah, 15. 15 big ones. All right, do the math. 3, 3, 4, 3, 3 significant figures. Now, notice it says both ways. When you're doing multiple calculations, there's 2 philosophies of rounding off. Round off at each step or wait until the very end. I'm a round off at each step person, but I'm not going to force you to round off the way I do. Am I nice or what? Don't answer that. But anyways, I calculated both ways, and not always are they the same. In this case, they are. Now, I'd highly recommend you go and look at, and I already did one like this in class, problem number 11. For quiz 3, skip number 9 for now. Now, one of the things I just noticed, bad Dr. White, I didn't put any Dalton law of partial pressure problems. So let's do one. Whoops, I started writing it. And most of you can't read cursive. Two days later, I'll be finished. I'm done. Everybody, thumbs up, people. Can you see it on the whiteboard? 7 points. Thank you, Gianna. All right, let's go through this. A mixture of AR, that's argon, and H2 is hydrogen gases, has an argon partial pressure of 341 torr and a hydrogen partial pressure of 101 torr. What is the total pressure of the mixture? Now, as soon as you see the words partial pressure, a bell should go off. How about a whistle should go off? It went off. That you should know it's time to use Dalton's law of partial pressures. And if you look at important information, which I'll have later up today or tomorrow for quiz 3, you see I have Dalton's law of partial pressures. And the total pressure, what this means is the sum of all the individual partial pressures. Total pressure is the sum of all the partial pressures. So let's do a little figuring out. What are we trying to find? The total pressure, P total. What are we given? The partial pressure of argon is equal to 341 torr. And the partial pressure of hydrogen gas is equal to 101 torr. And like I said, as soon as you see partial pressure, you know Dalton's law of partial pressure. The total pressure is equal to the sum of the partial pressures. Well, in this case, there are only two partial pressures, that of argon and that of hydrogen gas. And we took the time to figure those out from the word problem, and P total equals 341 torr plus 101 torr. If I add them together, and this I think I can do in my head, my first grade teacher would be happy. And this is the answer you get. And that's how you do Dalton's law of partial pressure. Oh, wait a second. I've got to let you try one. And let's have you try one. I'll be done before midnight. No, hold on. All right, let me read this. A mixture of oxygen gas and krypton, remember Kr, krypton gas, has a total pressure of 555 torr. And a krypton partial pressure of 102 torr. Then what is the partial pressure of oxygen gas? All right, let's do this stepwise. Everybody, what are you being asked to find and what are you given? Write that down, and once you've done that, give me a thumbs up. Again, all I'm asking you to do now is, what are you being asked to find? And what are you given? And we'll wait for everybody to finish. Times like this, I wish I had a recording of the game show music. You know how they ask a question, and while the contestants are thinking about it, writing their answer down, you hear that game show music. Nah, I won't do that. All right, give you another 15 seconds. All right, my turn. And if we notice, we're given a total pressure of 555 torr. So P total equals 555 torr. Torr is the unit of pressure. And we're given a krypton pressure, partial pressure, of 102 torr. And what are we being asked to find? The partial pressure of oxygen gas, PO2. Now, as soon as you see partial pressure, remember, you should be using Dalton's law of partial pressures. P total equals P1 times plus P2, and those are the individual partial pressures. Now, I'm going to help you out. What we're know now, P total equals partial pressure krypton plus partial pressure oxygen. Now, what do we want to solve for? This. Why don't you try that? And then I'll do it. Just the next step. How do you solve for partial pressure oxygen, PO2? Remember, anything minus something else is the number 0. And give me a thumbs up if you want me to do it. All right, I take the hint. All right, we want to solve for P2. P2, P oxygen, O2. We want it alone. So how do we get rid of the krypton partial pressure? Anything subtracted from itself equals the number 0. It's gone when you have an addition. So if I want to get rid of the krypton, I'll subtract partial pressure krypton. And this minus this is 0. So I'm left with partial pressure oxygen. However, whatever you do to one side, you have to do to the other. And I did. And I'll rewrite it here. And I like to rewrite it again. You don't have to. So partial pressure of oxygen, which we're trying to find, is P total minus partial pressure of krypton. And we took the time to figure that out so I can fill in those numbers. And subtraction is just like addition. You get the same number of significant figures to the right of decimal. These have none as the number that has the fewest. So I did my subtraction right in my head. Let me check again. That's correct. That's correct. And that's correct. And here is our answer. So that's how you do it. Any questions? All right, let's take a 5-minute break. Come back at 9:50. I'll go through the lab and I'll also go through, for those of you who need it, important practice for converting moles to grams and grams to moles, and just the basic understanding of unit analysis. You're a good buddy, you're a good friend. See ya in, well, let's make it 9:51 because it's 9:46 now by my clock. I'll see you in 5 minutes. I'm gonna get up and stretch. Oh no, I'm running late. Time to get started. All right, it's lab time. Now, listen very carefully, and I'll mention it again. Today's lab, you'll be working with some serious chemicals. You should wear your gloves. You should wear your goggles. I don't have mine handy right now. And I put on the apron. Now, for those of you with quartz or marble top, I would not do it on that surface. Take a baking pan and do it in there. Also, if you don't have that, you can do it in your sink, assuming you have a metal or ceramic sink, or if you want, go to your local supermarket and buy a super cheap aluminum baking pan. They're only a couple dollars. Jewel has them, everybody else has them, especially with Thanksgiving coming up. Wow, it's only a couple weeks away. Wow, where did this year go? Anyways, that's one thing. You'll be working with food coloring, dyes. Wear gloves. It'll stain your skin. Also, with a marble top, it will stain that too, maybe. I don't know. I don't have a marble top. And, I can tell you a story. A long time ago when I was in grad school, someone had a Halloween party, and it was a fun party, a wild party. But anyways, this one couple, married couple, came as Martians. They had a little antenna with lights on here, and their hands and face were green. And someone asked them, "How'd you do that? It looks great." And they said they used food coloring. Guess what? It took about 2 months for that to wear off their skin. You can't wash it off because it stains your skin. And they told I met them a couple weeks later when it was almost all off, more than a couple weeks. And the husband was saying, we're driving and a policeman pulled next to us and looked over like that because our faces were green. Be careful when you're using food coloring. Again, wear gloves, wear your safety goggles, and after you're through, wash your hands with soap and water because you don't want to get chemicals where you don't want chemicals. But anyways, let's go to today's lab. And let me close something. All right, everybody see on your screen, let me make it a little bigger this way. Exploring chemical, and thank you, Gianna. I guess I call J and GW. All right, now, in this lab, you will be investigating chemical and physical changes, and you'll have a number of activities. These activities are, well, you'll be mixing two things together most of the time. Now, notice they have here, you should wear gloves, goggles, and an apron. And some of the things are corrosive and toxic, and the candle is flammable. Now, important thing right here. How do you know if you have a chemical reaction when you mix two things together? Well, if you see a gas form, meaning bubbles, you will see a chemical, what you have when you mix two things together, that's indication of a chemical change. If you see when you mix two things together, a precipitate produced. Now, precipitate means in a test tube, you mix two liquids together, and all of a sudden you see a solid falling to the bottom. How many of you have ever seen those globes with the snowman in there, and you shake it up. My sisters had them. And all of a sudden you see the white particles coming down looking like snow. Have you ever seen those? Anyone? Thank you. Well, if you, both of you, if you're a chemist like me, you'd say, "Ooh, look at the precipitate in there when the particles are falling down." So precipitate means you form a solid when you mix two liquids together. When that happens, you've had a chemical change. Another one is if you have light form. And for this lab, other than the candle, you're not going to see any light form. All right, next one is when something produces or absorbs heat. What does that mean? Well, if you produce heat, it gets hot. The temperature goes up. If you mix two things together and the temperature goes up, guess what? You've had a chemical reaction. And if you mix two things together and the temperature goes down, guess what? You've had a chemical reaction. Now, the next one is a little tricky. A color change cannot be explained by simple color changes. If you have two things, one's blue, one's yellow, mix them together, and you get what green or whatever blue and yellow make, that's not a chemical indication of a chemical reaction. But if you have something that's clear, two things, and you mix them together and it turns red or blue or green or yellow, that color change means you had a chemical reaction. So if you mix clear things together and you have a major chemical color change, then guess what? Chemical reaction. Now, if you mix two color together, it either gets lighter or it changes color because mixing two colors will form that. That's not. So let's go through. You're going to be mixing things together today. And if it produces a gas, bubbles, you will have a chemical reaction. If you produce a precipitate, that means a solid inside of a liquid, you will have a chemical reaction occurring. If you have light form, that's only for the can. Oh, I gave it away. But that's a chemical reaction. If it gets cold or hot, production or absorption of heat, cold or hot, temperature goes up, temperature goes down. That's a chemical reaction. If you put two clear things together and the color change, that's a chemical reaction. You mix two colored things together and it changes, you don't know. All right, now for this lab, you're going to be working with water. And water you get from the tap has other chemicals in there, substances, and they're inorganic. That's what we mean by soft or hard water. There's certain ions, which you know what an ion is, in the water. In Chicagoland, calcium +2 is in your water. If you take my organic, I teach, and also I teach in 1105, that ionic substance in your water is what causes the bathtub scum in your bathtub. When we get into the chapter on acid and bases, I'll teach you all how to get that off your bathtub in 5 minutes or less using chemistry. But that's later in the semester. But because water has ions in it, for this lab, you will need, notice they have here, needed but not supplied, room temperature bottle or purified water. Now, if you want to really splurge, and it's not that expensive, go to a local supermarket, and I know Jewel used to have it, I haven't looked in a while, and buy a bottle of steam distilled water. If not, your bottled water should work okay. I don't know, but I would get the steam distilled water. Let's check something. I don't know if we can see it online. I'm trying to see. Hold on. No, I can't find it easily. I was looking to see if you could search for something. You can do it in Walmart. Oh, wait. Hold on. Not that I'm getting any kickbacks from this company. If you notice, you see on your screen there, they have Parents' Choice distilled water. They also have their great value distilled water, and that's $1.16 for a gallon. So I would recommend you do that. It's a lot cheaper than the other stuff you can get. I don't see any steam distilled water, but I have Sacramento here, but I'm sure your local Walmart has it. Either Jewel or get distilled or steam distilled water, because otherwise you'll get bad results. All right, over here they show the various equipment you'll need. Now, here they have the test tube rack, and you gotta build it by just pushing it. And you test tubes, you'll need your thermometer, and here's the various chemicals that will be in your kit. You will need salt, sugar, an ice cube, matches, and sandpaper, emery board, or something rough to clean the surface of your nail, which is iron. And you have the aluminum weigh dish. And here's your forceps. You have cups, you have a ruler, beaker, and your weigh boats. Now, what you're going to need also from the chem kit, be careful with these, the yellow and blue food coloring, and then these chemicals. Now, as I taught yesterday, this is 1-MHCl, 1 molar hydrochloric acid solution. This is a serious chemical. Be careful. You want to wear gloves with it. It's higher molar concentration can do damage to your skin and your eyes. This probably could too, not as bad as higher. And you'll also have sodium hydroxide. The 1 molar tells you concentration. Again, be careful with these chemicals. Here they have the various warnings you should read. And you should also have phenolphthalein solution. Now, follow the directions for each activity. Example, activity 2, take your 2 test tubes, add about 10 milliliters of water to 1 test tube, and then this is going to be a neat one, about 0.3 grams. If you're a little over, a little under, that's okay. In this second test tube, put the second test tube in a little beaker. You should have plastic one or cup, tare it, and then weigh in about 0.3 grams of the sodium polyacrylate, otherwise known as SAP, and you'll follow the directions. Oh, I should tell you, sodium polyacrylate, I did consulting for this chemical at one time. How many of you are familiar with the super absorbent diapers? Anyone? They're super thin and they absorb. Or how many of you are familiar with some of the super absorbent feminine hygiene products, otherwise known as Tampax, I think, the super absorbent one, they both use sodium polyacrylate as the chemical that absorbs the liquid, which is mainly water in a baby urine and a woman, also water. And that's a hint. It'll be something cool to look for. And you'll follow the steps. Same thing with 3, 4, 5, and 6. Now, let's look at activity number 4. Now, take the tea candle, make sure you're not near anything flammable, and light it. And watch what happens. Was there any heat given off? Light given off? Anything change with the wax? And that. Now, 4B, they say place a small ice cube on an aluminum tray and hold it underneath the flame. You don't have to do that. Take an ice cube, or if you've seen an ice cube in a glass, if you let it sit outside on a countertop for an hour, what's going to happen to the ice cube? You can look on YouTube, I'll bet they have that. So you don't have to do, it's the only one, 4B. I think you can figure it out. Now, if we go to page 12, you'll see this data table. And what you'll do, write down the initial and final color, initial, what each one looks like, clear or whatever. And if there's a final color change, what it is. Initial temperature, you'll measure that with a thermometer. You have that in your kit. And a final temperature. Now, here, observation. Did you see a gas form, bubbles? Write that down. Did you see a color change? If you did, write that down. Did you see a temperature change? And you can see if there's a major difference between initial and final temperature. Temperature change occurred. And did you see a precipitate? So there are 5 things. Gas form, bubbles. Number 2, did you see a temperature change? Number 3, did a precipitate form? Number 4, was heat, did it get hot or cold? And finally, number 5, did it give off light? If it did any of those 5 things, type of change would be a chemical change. If it just changed its physical state from a gas, liquid, or solid, that's a physical change. And I don't know, maybe one of these is neither. Now, after each activity, your big 250 milliliter beaker, you'll pour the contents of the test tube in, and you'll rinse the test tube once or twice with some of the distilled water or bottled water. At the end of the lab, and here you have both tables. At the end of the lab, what you'll do is the liquid in there, you'll dump it down your sink, flush it, let the water run for about 2 or 3 minutes, and then let it dry out, all the cleaned equipment, and return to your chem kit and clean the work surface. Now, all right, everybody see physical and chemical changes, student name on your screen right now. Oops. Now do you see it? Thank you. And if you notice, they have you copy over that table. And that's it. An explanation why you think it's that type of chemical change. So if you saw a gas form bubbles, you can say an explanation, well, gas bubbles were formed, and that's indication of a chemical change. Or nothing happened, there was no chemical change. And this is due next Tuesday. Now, what I will ask you to do is any one of these activities, take a picture of it and include that in your lab, please. All right, now remember, you should be wearing goggles for this lab. You should have gloves on, apron, or what I would do, wear an old long sleeve top. And be careful. After you're done, wash your hands. When you light the candle, make sure nothing's flammable around. And also remember it's hot, so don't burn yourself. And if you have a marble top, don't do these directly on there, or you might cause damage to your marble top in your kitchen. I would either use a baking pan, put some aluminum foil in it, or that's another one. You can, yeah, baking pan, put some aluminum foil and do that, or do it in your sink, assuming it's not marble. I have a stainless steel sink, so I would have done it in there. And any questions on the lab today?
I do have a question.
Go for it.
So for the column that says type of change, we would just have to put physical or chemical.
Correct.
Okay. All right, that's all.
Well, aren't you
Thank
glad
you.
I answer questions?
I am.
So am I. That makes two of us. All right, now what I'd like to do is spend some time and go through a area which a lot of you had problems on test number 1, and for quiz number 3, quiz number 4, quiz number 5, quiz number 6, and the final exam, or actually, and test number 2, you'll need to know how to do this. And remember, like I said yesterday, test number 1 for a lot of you, I hope, is the drop test of the either quizzes, 4 quizzes and a test, or 6 quizzes, no test 1. And you still have an opportunity to get a good grade. All right, everybody see the problem on your white screen right now? Thank you, Gianna. Both of you, John. Oh no, it's Gianna in stereo. All right, now, as all word problems, the best thing to do is first figure out what are you being asked to find. And you're being asked to find how many grams of water. What are you given? That you have these many moles of water. Now, as you saw for test number 1, an important information. I'm writing it here so you can see it. One mole of a compound equals the molecular weight of that compound. And the molecular weight of a compound in grams equals the sum of all atomic weights. in gram, and AT period, WT period is atomic weight. And that's in gram, not inging. Anyways, so there's only one number I have to start with. That's what I'm going to use. Be sure to write down your units. And what do I want to get to unit-wise? Grams of water. Now, if there was a ratio that I could convert, what's that ratio? And I'll use unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. Take the time to write the units. And where do I get these numbers from? Here. Remember, anything equal to another thing, you can write two ratios, A over B, and not equal, and B over A. So do I have a relationship of grams equal to moles? And the answer is yes, right here. 1 mole equals the molecular weight of a compound. Well, now we have to figure out the molecular weight of water, because that's what 1 mole equals to. And the molecular weight, and this was given to you in test number 1, and we'll give them to you in quiz 3, 4, 5, 6, test 2, not the ACS, but the molecular weight is the sum of all atomic weights. We have 2 hydrogen, 1 oxygen. Each hydrogen, you look at the periodic table, the 3 significant figures, the atomic weight is 101. Each oxygen, if you look at the periodic table, the atomic weight, the 3 significant figures, is 16.0. Do the math, add them up. Remember, when you're adding, you have the same number of significant figures to the right of the decimal as the number that has the fewest. And this has 2 to the right, this has 1. Which is the lower number? Hopefully you picked 1. So I keep the 0, use the 2 to round off, and the molecular weight of water using atomic weights of 3 significant figures is 18.0. Now, remember, this is 1 mole, this is the molecular weight. I saw people putting 1 gram, the 1 on top and the 18 on the bottom. That doesn't make any sense. Remember, look at this. You're going to be given that. Now, another important part of unit analysis. Notice moles and 1 over moles means it's divided by moles. And anything divided by itself equals the number 1. This cancels out, and I'm left with grams of water. What I saw on test 1, people would do something like this. And expect to get to grams of water. No. If we look at this, forget about the numbers. What is this? Moles times moles divided by grams. Nothing cancels out. If we look at the right way of doing it, and this the units, you have mole, and I should have put water here, times grams of water divided by moles of water. And I don't usually do this, but if I just do the multiplication division, I have moles of water times grams of water divided by moles of water. And notice right here, and look out, I'm going technicolor on you. This divided by this is A divided by A equals 1. That's canceled out, and I'd be left with grams of water. So this is important. You should know how to do this. Next, now that I do that, I can get my calculator, turn it on, clear it, 1.876 times 18.0. My calculator gives me this number. And a lot of you lost points because this is 4 significant figures, 3 significant figures, exact number, and for multiplication division, get the same number of significant figures as the number with the lowest. And which is lowest? 3 is lower than 4. So rounding us off the 3 significant figures, keep this one, keep this one, keep this one. That's my 3. Use that to round off. Is that 4 or higher or less, or 5 or higher? And 5 or higher. Therefore, I'll drop that. That's not what I wanted. And I'll increase this by 1. And that's how you do it. Now, I'd highly recommend, and I'm going to look at it and try and by Monday, put out an email. If you didn't do good on test number 1, what are key videos you should go back and watch where I do this? But the key thing is when you're doing these, and you're going to have to go from grams to moles, this sort of thing, for PV equal nRT problem. And therefore, I would go back, look at the video, today's video, and watch how I did this stepwise. And it's important that you master the, well, I don't know. If you want to do good in this class, then it is important. That's your decision. Listen carefully. Tonight and Wednesday, I'll have my office hours. If you can't make an office hour and you really need help, one, they have at COD online face-to-face tutoring that I believe is free. 2, if you really need help, as a special service to my students, mainly because Dr. White's selfish and likes to see students do well, because it makes me feel good, and I like to feel good. It makes my heart beat nicer. I will set up a special private tutoring help if anybody needs it. Email me and we'll see when we can get together on Zoom. The good thing is neither you or I have to go to COD. So with that, make sure for quiz number 3, you do on your own the practice problems for chapter 11 that I just went through. Go back and look at this video, but try it on your own first. If you have problems, come and see me. I'm here to help. I want my students to do well, but I'm not going to take the test for you. That's or quizzes. You have to do that. How you like that? You have to do that. Look at the eyes. So with that, I'm done for today, other than if you want, stop by my office hour tonight from 6 to 7:15, also tomorrow night, Wednesday night. And with that, I'll say, gang gesund. Bye now. Stole that from Granny and the Beverly Hillbillies.